Hello everyone, welcome to lesson 7-7, area and perimeter of similar figures. Let's jump right into the real world connection. Games. Foursquare is a ball game played on a hard surface. The court is 16 foot by 16 foot square divided into 4 equal areas. So let's divide our square into 4 even squares, okay? And let's complete question 1. Use the figure to draw a 4-square court. Divide each side in half. Okay, we're going to divide, so we cut it down in half and then cut that in half. Draw lines to divide the court into 4 equal areas. Done. Each smaller square similar or congruent to the larger square? Well, would it be? Let's say I first take the square and I cut it in half this way, right? So this dimension is being cut in half and this dimension is being cut in half. A half of a half is a quarter. So if I cut it all proportionally down, these are 1 to 4. You get it? 1:1 to 4. So if I quadruple the size of this square, 1, 2, 3, 4, it gives me the size of the large square. So is it similar? Well, yes. The length of each side of the smaller square is half of the length of each side of the larger square. So, for example, this length is half of this length, and this length here is half of this length. So half of a half makes a quarter. What is the perimeter of the larger square drawn above? What is the perimeter of the smaller square? Well, when I measure it on the actual textbook, it's 12 centimeters. Okay, that would mean that the perimeter all around each side is 3. Okay, so let me just zoom in here. Because it's the perimeter, that means I have 3, 6, 9, 12, right? So what would be the perimeter of 1 square? Well, here we have, if I'm only taking half of 3, I have 1.5 plus 1.5 plus 1.5 plus 1.5. So 1.5 times 4 is 6. Okay? So even though it's only a quarter the size, the perimeter is half. How is the perimeter of one of the smaller squares related to the perimeter of the larger square and the scale factor? Well, it is the perimeter of the original square, which is 12 centimeters, times the scale factor, which is a half. Okay, my scale factor is a half. You notice that the perimeter went down by a half, right? So I would take that and multiply it by a half, and I would get 6. Key concept. Perimeter and area of similar triangles. Similar figures. Perimeter. Words. What do we mean? If figure B is similar to figure A, which means they're the same shape and their scale factor is the same for all the dimensions, then the perimeter of B is equal to the perimeter of A times the scale factor. So you would have to multiply times the scale factor to get the transformation. So symbols. Perimeter of figure B is equal to perimeter of figure A times the scale factor. Okay, so you would multiply it and you would get that. So in order to go from A to B, we have to multiply A times the scale factor, and it gives us B. Okay, that's for perimeter. For area, if figure B is similar to figure A by a scale factor, then the area of B is equal to the area of A times the square of the scale factor. And it makes sense that it would be the square because area is squared. It's 2 dimension. How would that look? Well, area of figure B is the same as area of figure A times the scale factor squared. In similar figures, the perimeters are related by the scale factor, K. What about the area? The area of a similar figure is equal to the area of the other similar figure times the square of the scale factor, or k squared. Let's put this into practice, or see it in practice in example 1. Two rectangles are similar. One has a length of 6 inches and a perimeter of 24 inches. The other has a length of 7 inches. What is the perimeter of this rectangle? Well, when I look at this proportion, I see that it goes, for the rectangle, 6 to 24, so it quadruples, correct? What would it be for 7? Well, let's see. The scale factor is 7/6, right? Where we're comparing the two figures, right? Or you could say the two lengths. The perimeter of the original is 24 inches. What will become the perimeter of the next? So you go ahead and you take what we're looking for, your x. You take the 24 and multiply by the scale factor. You do a cross multiplication. Okay, cross product. Well, first you simplify by cross checking. Okay, and we see that we have 4 and 6, and then 4 times 7 equals 28. So the model of the new one is that. Now we can also do it different ways. We could do where we say that this is using the scale factor to multiply, but another way that I believe you've learned in the past is to say that 6 to 24 becomes 7 to what? You see? We can use cross product where we multiply the 7 times 24 and the 6 times x, so that we get something that looks like 6x, because 6 times x is x, equals 168. And then we isolate the x by using division property of equality. We divide both sides by 6 so that it cancels it out on one side, and we get 168 divided by 6 is 28. So I believe this is a friendlier way, or a way that you have learned in the past, a more familiar way. But another way, which works really well, is to simply take your amount and multiply it by the scale factor. And as you can see, the scale factor is a ratio, or a improper fraction. And you know, when you have an improper fraction, you have more than 1 here. Here you have 1 1/6. So you understand that when you multiply 24 by this value, you're going to get a greater amount, because this is no longer a fraction. This is an improper fraction, which means it's greater than 1. So let's go ahead. If you believe you got it, pause the video and try this on your own. Pause now. Okay, I hope you paused the video. Here we have similar triangles. Okay, we have triangle LMN, and is similar to triangle PQR. You can see that there's been some translations here, and the transformation has been perhaps a reflection over the y-axis, and a reduction in size. Okay, if we're talking going from this figure to this figure. If the perimeter of LMN is 64, so this entirely would be 64, what is the perimeter of PQR? Okay, PQR, saying that they're similar, so they both have reduced in the same proportionality. We can start by comparing our ratios and using the method they taught us, where we have a ratio of 18 to 24. Now you understand that this ratio, right, 18 to 24, okay, this ratio can be simplified because both of these are multiples of 6, where I have 3 6 on the top, because 3 times 6 is 18, and 4 6 on the bottom, because 6 times 4 is 24. So it's essentially 3/4, right? 3/4 is really our ratio. I will take my perimeter. They've told me that it's 64 my perimeter for this one right here, for this triangle. That's 64, right? So I'm looking for the perimeter of this one. So I will take my 64. Okay, now I'm looking for the new perimeter. That x is representing the perimeter of the small one, which is the one I'm looking for. I will take my value of 64, and I'm going to multiply it by my scale factor, which I've already determined is 3/4, because I simplified 18 over 24, 18 over 24 as you see it there. And when I do that, I multiply. I can use my cross-reference. I cross-reference 4 down to 1 and 64 to 16. And now I simply just multiply across the top, 16 times 3, right? Because don't forget that this 64 was over 1, right? All numbers are over 1. And when you're multiplying fractions, you cross-reference. I cross-reference, I get 16 times 3 is 48. So x equals 48. Therefore, the perimeter of this triangle here is 48 if the perimeter of this one is 64 and they have a scale factor of 3/4. Let's try it again, but now we're going to apply it to a real world scenario. In a scale drawing, the perimeter of the garden is 64 inches. Okay, so we've got 64 inches in this entire perimeter, the distance around. The actual length of AB, line AB, is 18 feet. What is the perimeter of the actual garden? Okay, so over here in this scale, we have 24 inches. But in the real garden is 18 feet. So not only are we changing the unit, but the amount is different. So all we have to do is we have to use a scale, right? As they have here, 18 to 24, correct? And there it is, 18 to 24. Now that we can simplify the scale, don't forget, okay? But before we do that, we need to change it to a scale factor. Don't forget that a scale factor uses the same unit of measurement. That's important to know. So what is 18 feet in inches? We convert that, so we have to multiply each foot times 12, correct? Because there's 12 inches in each foot. And when we do that, we get 216 inches over 24 inches, or simply a scale of 9 to 1. Now that we have our scale, we're going to take our 64 inches, right? 64 inches, the perimeter of this drawing. And we're going to multiply it by 9 to get our 576 inches of the real life-size garden. And then 576 inches can be expressed as feet if we divide it by 12. We divide this by 12 and we get 48 feet. Another way that I would do it would be even simpler, would be to not even bother with the conversion of inches and feet back and forth. Just treat it as if it's all the same unit. And I would do something along this line, where I take this scale factor again, right? And remember that 18 over 24, again, can be just simply expressed as 3/4, right? Because we have 3 sixths here and 4 sixths here, 3/4, right? 3/4. So we can just simply take that scale factor, and we're going to take our 64, okay? Our 64 inches. Again, I'm not using units. I'm going to multiply that by 3/4, and that's going to give me my 48. Now, don't get tricked. We got our 48 as we were looking for, but now you have to understand that in the map it's in inches, but in the real world it's expressed as feet. So don't forget that you have to include the feet yourself, and don't lose track of that. That's a much simpler way to do it. But if you want to make sure that you do get the official scale factor in inches, you do that, and then you can always convert it back to feet as they did in their therefore statement. Okay, here we have another translation, okay, or transformation, I should say, where we go from a smaller quilt to a larger quilt. And we see here 2 quilting squares are shown. The scale factor is 3 to 2. What is the perimeter of square TUVW? TUVW, right? So they're squares. So that means this is 4, 4, 4, and 4. So 4 times 4 is 16. So here we have a perimeter of 16 inches, right? 16 inches. And with a scale factor of 3 to 2. 3 to 2. So I guess, or 2 to 3. Right, because it goes larger. So this would be our 2 and this would be our 3. So they're saying that this part is 2 parts. Okay? This in here there's 2 parts to 3 parts. I mean, proportionally speaking, you should probably be able to understand that If we break this 16 down into two parts, we get 8 and 8, don't we? Right? This would be our scale of 2, factor of 2. And to make it 3, well, we just do another 8. 8 and 8 and 8 is our 24. And there's our answer. Now, I am not using any of the methods used in the text. I'm simply showing you guys logic and proportionality, using proportionality to solve. So it would be 24 inches, right? Now let's do it the way the text has taught us to do it. The way the textbook wants us to work is we have to identify the first perimeter before we try to convert it to the next perimeter. And we already know that the perimeter of the small quilt is 16 because it's 4 plus 4 plus 4 plus 4, or 4 times 4. So we get x equals 16, right, our perimeter, and then we use our scale factor of 3 over 2, right? In our scale factor, which we have it here written as a ratio, we can write it as a ratio like this as well. And we can work with that. We place it, it's like multiplying fractions, right? And we go ahead and we multiply across. So we have, we reduce our, or do a cross reference to reduce, where we have multiples of 2 on both sides. Here's 1 and here's 8. And then we simply multiply across and do 8 times 3 equals 24. And it's going to be 24 inches. Okay, that's what we're using, 24 inches. So that's the way to do it, and the way the textbook showed us. But I really just wanted to show you logic before that. Because in the end, logic is what's going to save us in the real world, in the moment when we are having to work with these things in real world context and we don't have a book in front of us or equations or so on. So let's see here. Number 3. It looks like we have, this looks like the roof of a house. Okay, let's read. The Eddingtons have a 5-foot by 8-foot porch. Okay. 8 foot by 5. So right here, it goes up 5 by 8. Okay. They are building a similar porch on the back with double the dimensions. Find the area of the back porch. Okay, so now we're using area, and it looks like we're going to increase. So we have 5 by 8. This, our area is length times width, right? So our area here is 8. 5 times 8, which is 40. We have an area of 40 feet squared. Don't forget that. And now they're telling us they are building a similar porch on the back with double the dimensions. Find the area. So double the dimensions means that the 8 converts to 16 and the 5 converts to 10, right? So it's 10 times 16, which makes it 160. It quadruples in area because you're doubling each dimension. You double this and you double this. Just like the very first example we looked at, the 1/4 of the area becomes quadruple of the area when you double each dimension. Okay, so the factor is 2. The reason the factor is 2 is because that's what we're doubling it. That's the scale factor. In our proportions, okay, our area is solved by multiplying the 2 dimensions together, so we get 40 square feet. So we take our 40 and we multiply it by our scale factor squared, because now we're looking for area. And our scale factor squared is 2 to the power of 2 is 4. And then we take 4 times 40 is 160. Don't forget to follow order of operation. First we do exponents, then multiplication. The back porch will have an area of 160 square feet. And we're down to our last example. If you think you can do this on your own, please pause now. Okay, I hope you paused the video. Here we go, let's read it. Malia is painting a mural on her bedroom wall. The image she is reproducing is 4.8 inches by 7.8 inches. If the dimensions of the mural are 10 times the dimensions of the image, find the area of the mural in square inches. Okay, so it's 10 times the dimensions. So these numbers have to be multiplied by 10 so that we can get, and then they want us to find the area of the mural in square inches. Okay, so we can change these and multiply each one of these by 10. When you multiply these numbers by 10, the decimal simply moves one place to the right. So now our new dimensions are 48, okay, by 72. You can probably think of a few different ways to do this. Let's try it the way the textbook is teaching us. First, let's identify what the area is for the image. Okay, so we're going to take our length times width. Okay, area equals length times width. So when we multiply 4.8 times 7.2, okay, we get an area of 34.56 inches squared. Now we're looking for how this is going to change, so we'll take our or how it's going to be transformed. So x, which is the new area, is equal to our smaller area, okay, our original area, times the scale factor. They're telling us is 10 times larger, okay, squared, because it's area. So we solve by order of operation, and this becomes 100, because 10 squared is 100. And when you multiply anything by a base of 10, so this is 100, you count the number of zeros. That's how many times you're going to move the decimal place over. So 34.56 becomes x equals 3,456, because the decimal moved over 2 places, the same number of places as the zeros you see there. And that would become inches squared. And as always, here's our guided practice. This is how we will begin class. Please take a look through it. Make sure you understand the content or what you're being asked to do. If you don't, go back to the videos to the proper examples. As you see there, they're outlined. And if you have any questions, bring those questions to class. See you then, everyone.